Okay, I'm sorry about that. We had a true solid hang of the computer. Uh, uh, there's a new stream out there. Let me just tell people to rejoin because I had a bunch of people in there already and it hung up. Okay, if you can't see me live, it means that you need to rejoin. Okay, let's do this. And we've still been taking pictures. My computer hanged, but the computer out in the building 2,600 miles away was still going strong and still capturing images. We're up to 40 images of this now during that time. I'm glad you guys can see me. Those hopefully realize I'm not hiding on you. I haven't gone away. I did say hello to those of you, some of you before. Hopefully I'll say hello to you guys again. Hello to Michael Hedrick, Tim F. Woohoo! Michael Galea, how you doing? Karen Belmont's here. Renee Cruz, Daisy Zoe Amethyst, Lubo in China. Hello, Lubo. How are you over there in China? This is M33, correct? Donald Kunzer's with us. Catherine Messick is back. Yes, we are back. And, of course, Daisy and Zoe are with us as well. Cosmic Flow has joined us again. And William Connolly from Bethel, Connecticut. Hi, Bill. How are you? Nice to see you. Okay. Bill, I was just down your way. Bill Connolly. I was just on your way because I was doing a investigation, a UFO investigation down there with Ben Hansen, a friend of mine. You know him from a lot of television shows. Many of you know me from a television show called Proof is Out There, but Ben asked me to join him on an expedition to go out and hunting for UFO that had nothing to do with these drones. And when I got there, next thing you know, we're with the Reading, Connecticut Police Department going out on a call looking for drones, which is very exciting. We didn't see one, but that's the unexciting part. But, it was pretty cool either way. It was a lot of fun. So we do have a lot of drone sightings, but as the Mutual UFO Network's chief photo and video analyst, guess what I get? I get all kinds of photos of regular aircraft that are mistaken for drones. Anything in the sky with a flashing light now is called a drone by a lot of people, and that's unfortunate, but I understand it. I understand it because it's kind of crazy to expect that our skies, have something flying around like that nobody really understands at this point. And that's kind of what we're seeing, So what I want to show you, this is Mesher 33, as I said. Let's zoom in a little because we certainly got enough to zoom in on. Look at this detail in here. Now, over here, that guy right there, you see that? You know what that is? This right here is a nebula, just like in our galaxy, that might be called like the Eta Carina Nebula in our galaxy. Now, the Eta Carina Nebula size is what I'm talking about. Okay, but look at that. That's beautiful. That is a giant star-forming region, a massive star formation region right there, and it's really, really pretty. It's like I want to eat it up. It's big. Okay, massive, and we're seeing it from 2.7 million light years away. Okay, there's another one right here. Okay, that you can see right there. See that guy? Okay. And if you look around, you'll see these green areas. You know what that is? That's a supernova remnant. That's the remnant. When we look at the Veil Nebula, guys, we see the Veil. Okay? It's got that filamentary structure. This is what something like that would look like from 2.7 million light years away. And that's 2.7 million years ago that this light left. So it had already happened in this galaxy's history. So there's a lot going on in this galaxy that's fun to watch. Okay? And as we move down a little bit, you'll see another nebula region right here. Okay, there's another one in here, another one in here. You can see a string of them. You can see this is that supernova. Then right here, you've got this spiral arm. This is one of the spiral arms. Okay, we got another remnant right here. You have a spiral arm here, and this cluster here, this cluster of stuff you're seeing, these are stars that have formed in this galaxy, in the star-forming regions that are the spiral arms. Let me increase the contrast, help bring that out. So now you'll notice also as we move down, you'll see that in the middle of the galaxy, it seems as if the color tends to be more of a yellow, and it really is, because those stars are older. Then out here in the spiral arms, you have young stars, a lot of activity with these nebulae that are forming new stars all the time. And then what happens is they start orbiting the galaxy, and you leave a string of stars. There's a string of stars that were formed in nebulae like this guy and like the one up there that we just saw. You'll also notice in here we have material that looks like this dark brown stuff. That's actually the dust formed from countless billions of supernovae that occurred in this galaxy. And when those supernovae occurred, that dust was scattered throughout the galaxy, and then the turbulence of stellar winds and galactic rotation helped spread it around the galaxy, and it formed fertile regions where more planets and stars could be formed from the hydrogen that was dragged around with it, and from the dust that would then make planets. So we can expect that there's a huge number of planets in this galaxy like we have in our galaxy. This is over here. We talked about that supernova right there. Now here, we'll zoom in on this. Here's another supernova remnant. Check this out. Let's zoom in. Okay, check this out. Okay, you can see there's a central remnant, but then you got this roughly elliptical, probably a shell of stuff around the outside of the remnant in the middle there. And that remnant is something that is pretty incredible. Okay, now when we look here, we see another cluster of young stars here, a cluster here. And one thing that we do in astronomy, and many of you know I'm a professional astronomer. That's what I went to school for. Go figure. I didn't want to make any money, right? But what happens is when we, okay, where'd that go? Let's bring that back. Our Starlink satellites are playing games with us tonight, but don't worry. I'm going to make sure that we stay live. Okay, so when we look at something like this, and we look at this here, one of the ways that we do in astronomy is we'll actually take a look at the inverse of things. Like for instance, we'll invert an image like this. Okay, now you see that all the light stuff looks dark and all the dark stuff looks light. So this helps us figure things out in some cases. And if we remove the color, you'll see it like we see it in astronomy when we take pictures. This type of image will help us see things better, much better in some cases. So look at the supernova remnant, how it looks now. Now we don't know what color it is right from here, right? So obviously it's a negative. But, sometimes people say, wow, look at this beautiful picture I got of M33, and they show a beautiful black and white image like this. But there's no knowing whether this nebula is an emission nebula that makes stars, or whether it's a supernova remnant, or whether this is one of those emission nebula that makes stars and planets, or it's a supernova. The only way you can do that is by doing a spectrum of it, or by putting it into color. And when you put it into color, you immediately see the difference. Now, all the blue you see, that represents young stars. Okay. Now, it's really very pretty. I'm gonna actually, I'm gonna do something here that you've seen me do before. I'm gonna back out, go to the full frame, so you'll see the full frame on the screen there. There it is. Okay, and now what I'll do is I'm going to do a identification. This identification shows us everything that this particular program knows in here, and I'm going to save this image with the annotations. And when I save it, well, actually I shouldn't have saved it yet. I should have done this. I should have set the target name. So let me come back here, select this, and say set target name, and it might complain. Okay, and it does. Okay, so we'll say yes. All right, so now we'll say save image annotation. So now there'll be an image in a directory for the Triangulum Galaxy Measure 33 that will have all this stuff identified, so you can zoom in on it, check it out. That picture looks like this. Okay, here's what you're going to get on our server. So if you zoom in on that stuff, you can see all the different ones. Now, I know they overlap a little bit, but you can at least see where they are, and we'll get identifications for you at some point if you wish. Okay, so that's our annotated image. I like doing annotation at the same time. Hello there, Jeff Penn, by the way. I forgot to say hello to you earlier. It's nice to see you joining us tonight. I think I said hi to Cosmic Flow, and Alicia's with us. Hi, Alicia. Alicia Veras is here. Ta-da! Yeah. Okay. So, Fantasy's with us. Nice to see you. So now, let's see. We've got 61 images. So we're going to save this now as just a regular image, and we're going to be able to process that for you. But if you want just the image itself, well, then what we do is we just basically save this image exactly as seen, just like this. Okay. And then what you get on the server, literally, as the time it might take you to go there, is you'll get this image. This is up on our server. Where is it? SkyTourLive.org. Go up there, scroll down, and it'll say, take me to cool pictures, and it'll explain what to do to get into our directory structure. Okay. I may give you a tutorial on that at some point in the coming weeks. So this is the beautiful image that you'll have available to you, and this is what it looks like. You can see these objects in here. You can identify them. Some of these smaller objects in here, by the way, some of these little tiniest of objects, you know what those are? Those are globular clusters that are in this distant galaxy. So there's many globular clusters that are also in this galaxy, which is really cool. Okay, so here's our live view again. So this is neat. So we just got some beautiful imagery here, and I'm gonna hurt your eyes by showing you this. This is my ugly sweater for the ugly sweater contest my niece is running. Well, you can't see it now, but let me see if I can get it back. No, it doesn't want to show you. See, it won't show you. Okay, what it is it's actually Darth Vader with a Santa hat on, and it says Merry Sithmas. Oh, terrible. Got it specifically because it's terrible. It's a good ugly sweater, but I'm in the mood, I'm in the season, so why not, right? Okay, several things, just a little housekeeping for you guys so you know. We're closing in on putting in the second telescope. It looks like now we have an installation date. It's probably going to be late January, early February, sooner possibly. And then we'll have an 11-inch telescope out there that we will be able to do narrowband imaging with, along with spectral imaging, and that will be installed. So eventually this telescope is going to go in the same building, and that's down in Benson, Arizona. Right now I don't see any need to move it from where it is, but we were having some issues with Starlink, and don't know why, and we'll figure it out. But the bottom line is that where we're going, we have much better internet, and so it should be a lot better. Okay, we're going to save this one more time and move on to the next object. Okay, we'll save this and save it exactly as seen. Okay, now Alicia says she has a dumb question. Do different galaxies have different gases, or do they all contain the same? That's not a dumb question. That's a very good question, because somebody else in here probably wonders that. Okay, the bottom line is that every galaxy will have certain abundances of dust, certain abundances of stars of different kinds, certain abundances of gas, neutral hydrogen, or what have you. And some galaxies, like elliptical galaxies, have very little dust, and in some cases very little additional gas. Galaxies like this one, on the other hand, are loaded with dust and loaded with gas and loaded with stars of many different types. That's something that doesn't always exist in the universe. So that's not a dumb question. It's actually a very thoughtful question. So not bad. Even Darlene, your daughter, who was sneering at you in the back seat in that picture you put on Facebook, will appreciate that. So anyway, just wanted to say hello to Victor Anthony. Sam S., did I say hello to you? So anyway, yeah, so okay, we're going to do this one last time, and then we're going to get out of here. Okay, so now we're leaving there. The Triangulum Galaxy is up on the server now. If you go to skytourlive.org and start scrolling down, you can actually see what's going on. You can actually get to all our locations and see everything we offer. You know, if you like what we do, I would encourage you to donate. I mean, you can help us keep going, because we definitely could use you. We have an observatory to put this new telescope in, and we would love to be able to get the funds to maintain it and keep it going, because we spread astronomy to the world and we don't charge a dime. I don't make a dime on this, so we work on people that donate to us. So if you can provide any donation, join our Patreon. We'd love to have you join the Patreon. We would love to feel the love from everybody who joins our Patreon. You can join for $3 a month, $5 a month, 10, I think, 20, 25, whatever you feel comfortable with. And that way you can enjoy what we do, and we can keep bringing it to you with better and better quality, because that's the kind of thing that we're trying to do now. All right, let's go to our additional planetarium system here. And we're in a neighborhood, so we might as well look at the Andromeda Galaxy. Now, we just saw Messier 33. You saw how unbelievably dusty it was. Let's now go to another galaxy that doesn't look as disheveled or messy. Okay, Messier 33 is called an SC galaxy. It's a galaxy that's a spiral, but instead of an A where the arms are tightly wound, or a B where they're not so tightly wound, or a C where they're kind of loose, like a loose pinwheel, Andromeda Galaxy is a different one. This one is a galaxy that's like an SA, which is sort of tightly wound arms, but it also has qualities of the B, which is the SB spiral, and B, less windy. Okay, and so we'll check that out now. Let's go there, and we'll come over here, and you'll see the telescope is going to move and take us up there. Here we go. See the telescope moving up there, and here's the Andromeda Galaxy. And we're going to see some really cool things here. Remember I talked about elliptical galaxies? Well, this is a spiral galaxy. It's sort of on edge there. Okay, but then up here you have another object right there. That's another galaxy. It has two satellite galaxies. And then if we move a little bit to the west, this is such a big galaxy we can't fit it in the entire view. It's several moons across. Okay, and now what I'll do is bring it over here. We're going to do the bottom half of the galaxy first, and just show you what's going on here. All right, so now let's go south a little bit, but we're going to keep this in the view. All right. Okay, and here is the other galaxy. This is another galaxy in this region. So this still goes further south. So I'll catch that other one on the next trip. We're going to just go down south here a little more. Okay. All right. So the Andromeda Galaxy, unlike Messier 33, this one is 2.4 million light years away. So all the light you see coming from it was left at 2.4 million years ago. I like to compare, as I've mentioned to you a few times, what happens when you think about what was going on Earth 2.4 million years ago. That's when the light you're seeing right now left that galaxy. Really cool. Okay, this goes all the way out of the view. We're not going to catch all of it, but we'll try. to get some of it. So this will be a 25-second shot. Again, the telescope is pointing pretty much straight up, so it's doing pretty good. All right, and this over here, these numbers here mean that we're guiding on this right now. And this down here is our progress bar. This tells you how far along the exposure is. When it goes all the way to here, one shot's done. We're doing 25 seconds worth. So I'm going to get out of this and go into our live stack, our deep sky mode. And this is the previous galaxy we shot, and that's already been saved, so I'm going to clear it. And the next image that'll come in will be the Andromeda Galaxy. There is the lower end of the Andromeda Galaxy. Yeah, and that's beautiful. So let's color correct. All right. Now all these stars you see here, these are here. They're all up in the foreground. They're in our galaxy. Everything in the galaxy, the Andromeda Galaxy, is way out here, millions of light years away. Okay? You can't see the stars in the Andromeda Galaxy without a telescope, kind of like the Hubble, you know? Hello, Linda. Linda Judd is with us. Linda's with us. Nice to see you. And I see Keith Evans. Hi, Keith. How are you? Nice to see you. So, yeah. So here is the beginnings of this exposure. I'm going to modify it a little bit. This is our dark level. This white curve is the average of the red, green, and blue curves. And it represents all of our data. So if I move just to the left, you'll see it's going to get a little bit lighter, but we'll see a little more of the faint detail. See? And that's what we want. This is our mid-level. This brings in the detail all around, and you'll notice that the nucleus gets really blown out if we bring it really close. It becomes like a massive galactic-sized supernova. But we usually leave it down here, about there. Now, like Measure 33, do you notice there's a blue section right here? Look at that. That stands out, doesn't it? There's another one here, and there's another one out here that's pretty faint. Okay? And this is one of the star-forming regions in the Andromeda Galaxy. And one thing that's more regular in this galaxy are these rings of dust, these spirals of dust. Do you see that? These spirals of dust go around the galaxy, and they are part of the fact that when a star goes supernova, the material starts orbiting the galaxy, and everything tends to go into a disk. All right? And it starts with the original mass going in the galaxy that form a disk around an object. That's a physics concern. That's how it works when you have objects in orbit. They will tend to be all disheveled at first, but they'll all tend to go into a disk. And like a black hole, it has a disk around it, and it's called an accretion disk. Material going into the black hole is accreted, or brought in from that disk. Okay? Captured from that disk. So here we have the Andromeda Galaxy, 2.4 million light years away. We'll darken it up a little bit. We've got 7 shots so far. We can probably zoom in on this a little bit just to show you, because there's some details in here that are really cool. You can see the stars here, this star field. You can see this one here. This is what's called an OB association. Where's that come from? OB associations are type O and type B stars. I know that's a blood type, but you have O, B, A, F, G, K, M, and they go from hottest and bluest to coolest and reddest. Okay, we're a G. So we're not an O, which are the hottest stars in the universe. We're not a B, which are the second hottest, or an A, or an F. We're a G star, kind of whitish yellow. Okay, the K stars tend to be orangey, and the M stars are very, very red. Okay. In fact, it's thought that because M stars are the most common star in the entire galaxy, they've lived the longest of any other stars. And the very first M star to ever be created in the universe has yet to die, has yet to go supernova. I won't go supernova, but has yet to go and shrink down to a white dwarf. They last trillions of years. The universe is only billions of years old. Baby compared to the M-star lifetimes. So it's thought that M-stars may have, in fact, we see the M-stars seem to have most planets that we see in the sky we'll find around M-stars. And that's pretty cool. Okay, so when we talk about M-stars, we have to understand that if there's going to be life in the universe, it may be around an M-star. And we have to ask ourselves, what would that life look like? I do, as many of you know, I do lectures all over the country. And one of them I do is I talk about the effects of different stars on the evolution of potential life on planets around those stars. That is really, really incredible, because if you think about M-stars, their planets are very close to the star, because the stars are about 1/100th of the output of the sun. They're literally only a little bigger than Jupiter, the planet Jupiter, and they are like mini Jupiter systems with their satellites rather than star systems with their planets. Okay, they're so small that every single planet that's in the habitable zone of an M-star, okay, is so close to the star that they measure their year in days. Now, I mean, we have 365, but they measure it in single days. Like it could take them 6 days to go around their star once. And that's a year for them, from in our understanding of a year. Okay? One time around the sun. So that's interesting, because you also have another consequence. When those planets are that close to their star, they're also tidally locked, meaning they have one face facing the star. So they're going around the star with the same face facing it. Kind of like the moon going around the Earth. Okay? So the moon going around the Earth is locked to our Earth, and the planets going around an M-star are locked to the planet. What's that mean? It means that on the sun side, it's always sun. It's always noon. It's always brightly sun, bright lit sun. On the equator, not the equator, but the terminator, where you're going around the planet, where it's half, where you're at the sunset side, you can have a ring of sunset side on that planet that's facing the star. That's a perpetual sunset. And then on the other side, you have perpetual star nights. Okay, so if you're a real estate mogul, you might want to think about now, get in early, get some property on the M-stars, or around the M-stars, get planets, buy a planet, and make it a tourist attraction. You could advertise 24/7 beaches, you could advertise 24/7 sunsets, and you can advertise 24/7 night skies. In fact, you could advertise an entire year of night skies around that star in just a 7-day vacation. I mean, it's kind of cool to think about. But the creatures that might live there, that's a different story. Let's consider that on the dark side of these particular planets, which is always in darkness, it's going to still be warm enough, because the heat on the sun side is going to cause large winds to blow into the back and mix the atmosphere. So even if the atmosphere is a little turbulent, it's going to be warm on the back side. So if you're on the back side, you're always going to be in darkness. So as we've noticed with caves here on Earth, cave life doesn't have any color, does it? There's no pigment in the skin of cave fish. They're white. And many of them are blind, okay? But if you're on the dark side of a planet around an M-star, you'd still have a use for eyes. It's not pitch black, because you've got the stars. And if you want to see in the dark, you're going to evolve bigger eyes. And isn't that just what we see with the gray aliens? They're gray, devoid of color, and they have these big giant eyes. So one of the ideas is that these types of creatures would come from M-stars. And this would explain why there's so many of them seen here on Earth. Because if they got to a technical level where they could harness interstellar travel, I think that's pretty cool, And they'd be able to actually, make their way to us, So there's a lot of really interesting ideas that go into that. And this galaxy, 2.4 million light years away, as I heard Fantasy said earlier, it's going to eventually collide with us, and that is true. But what will happen is it's going to kind of go through us. And then our galaxy is probably going to get whirled around and become part of this galaxy. So this galaxy is much bigger than ours. Our galaxy has anywhere from 150 billion stars to maybe 400 billion stars. This galaxy here has over 1 trillion stars. It's literally twice the size of ours. At the high end, it's about twice the size of ours, roughly. So it's got a lot more mass. So we're going to be subject to it when it comes through. We might actually rip it apart slightly. And then the two galaxies will merge and form a new type of galaxy. Now, one of the things that you should be thinking, if you haven't, is what about the big supermassive black holes, Mark, in the center of the Andromeda Galaxy and the black hole in the center of our galaxy? What happens to those? That's something to think about. We've witnessed what happens when black holes collide and merge, haven't we? We see something. How do we know? How do we know when black holes merge? Write it in the chat if you know how we detect the merger of black holes. Because that's what's going to happen here. All right? I'll wait for that. Fantasy says Hawking radiation. No, yes, there's going to be Hawking radiation at a black hole natively. But in the collision, there's something that we see that tells us black holes just merged. It's very striking. And I'll give you a hint. It's something that Einstein said we'd never see. Kevin says pulsar. Good comment there, Kevin. Not a pulsar. Mort Ort got it. A pulsar is the result of a supernova that doesn't go to a black hole. Mort Ort says gravity wave disturbance. That's true. And we'll see a gravitational wave ripple effect in the local universe. It won't rip us apart, but you'll just see it come through. Ripples like ripples in the water. Linda said, is it true that every galaxy has a black hole? It looks like most galaxies have one of these SMBHs, or supermassive black holes, at its center, yeah. We have one. Okay. Keith Evans says a quasar. A quasar is actually a little different. A quasar is an active galactic nucleus, see? So that's not a... Curtis Horn got it right, yeah. Gravity waves. I know he probably said it before, too. I'm drinking my Thai tea. It's an orange... It's not orange tasting, but it's a orange-looking Thai iced tea. I make it from scratch. I love it. And Mort says, what instrument on Earth will detect it? It's called LIGO, the Laser Interferometric Gravitational Wave Observatory, LIGO. There's a counterpart in Italy called Virgo, okay? And in Hanford, Washington, and down in Louisiana, there are 2 LIGO detectors, and there's one in Italy. And judging by the time of impact of these gravitational waves through LIGO Hanford, LIGO Louisiana, and LIGO Italy, or the Virgo Italy, we can detect where it's coming from and so forth, and that helps us pinpoint the location. It's pretty cool. Mr. Django's with us from Belgium. How's it going, man? Yeah. Now we're back. And we're back. The other stream kind of... well, what happens is the computer just blew up on me, hung, and I don't stand for that. So I had it back in record time. That was actually pretty good. Do you think gravity has a frequency? Linda Judd asked. That's really good to ask, because we don't know if gravity has a frequency. What we can tell is there is a frequency associated with the ripples coming from a merging black hole pair, and that will produce a frequency, a ripple frequency. But does the gravity itself have a frequency? That's different, and we don't actually know that. We don't actually know anything about gravity other than how to calculate its effect on us. And that's because gravity is not something that is confined to our 4 dimensions, X, Y, and Z, moving through time. And I'm not the only one that talks about this. Other astronomers talk about this too. gravitational waves and so forth, we understand. But one thing we don't see are gravitational particles or gravitons. Okay, we know that light operates within our four dimensions. We have the ability to reflect it, we can refract it, we can block it. Okay, we can't do that with gravity. And all the fundamental forces and the fundamental particles, right, for the most part, can be described with what's called a dual characteristic. They can be described with an equation, a wave, and a particle. An electron is a particle, and it's also a probability equation. All right. Light is a photon, okay, or a wave. And that duality is what we see at the fundamental level. Gravity is a fundamental force as well. And we never knew about gravitational waves until we detected colliding black holes. So now we have gravity waves. Where's the gravity particle, the graviton? That's hard because with light starts and stops in our four dimensions. It starts and ends here, okay? The electron, okay? Its probability distribution starts and stops in our four dimensions. It doesn't go interdimensional. Gravity is a weirdo. Gravity is out of its mind. It's out of its dimension, okay? Because what happens is gravity seems to start here, okay? And it seems to end somewhere else. And so it starts in our four dimensions, which is why we can calculate its value. But it ends in a different dimension, seemingly. Now, where do I come up with that? Well, I come up with that from a study of string theory and the concept of Randall-Sundrum 1 variation of string theory, which says we have four dimensions, and then there's a fifth one out here, okay, right here, that fifth one. And that one is a dimension where if you enter that dimension, you go further up my thumb, you go into a universe that's getting smaller and smaller around you. And so if you can get into that fifth dimension from this four dimensions, you could say, I can travel 12 inches in this four dimensions, and I will be going 12 exact inches in this four dimensions. If I can get into the fifth dimension here, not the band, okay, if I can get into this fifth dimension, if I can go in somewhat, I can travel 12 inches again, but when I come out, I will have found that I traveled this astronomically large distance, maybe from here to Pluto. Okay, so, but when you go into that fifth dimension from the four, you literally do something that we're not used to seeing. You vanish right before whoever's watching's eyes. If this glass went into the fifth dimension, it would literally be gone, and I'd be sitting right here like this with nothing here. But where's my glass? And then it could pop back in at another location. And it wouldn't travel from here to that new location by going the distance across the room to that new location. It would literally vanish from here and appear over there. It would punch out of our four dimensions, go into the fifth, and punch in at that new location. So the path it's taking is from here into the fifth dimension and then out to that other spot. The in-between space, it doesn't even travel that space. Now, why am I talking about this? Because if there are creatures out there in the universe, that's the way they're getting here. I'm not the only one that thinks this either, okay? I've worked, as you know, with Avi Loeb from Harvard, and he and I worked on a few productions together, one for ABC, another here and there, and we were on podcasts together. But he came out and said recently that he thinks aliens may also be traveling interdimensionally. Ding, ding, ding. Well, this is probably how it's going to work. See? So now I think that we're talking about something that is going to be workable for us sometime in the future. Sometime in the future. Not now. Correct. Not now. But at some point. So we're working up to 43 images here. I'm going to grab our location here and look at, and we're going to just do what's nearby. We're going to get the Andromeda Galaxy right there. Measure 31. We'll set the new target name. Okay, there we go. And I'll save the image with the annotation right there. Okay, it's been saved, so now that's out there in the Andromeda Galaxy directory on our server. Okay, and now we'll save it here with 43 captured. And I'll say save exactly as seen. So now you get the whole bottom of the galaxy, all right, with 43. So let's zoom in and just move around a little bit just to show you some cool things. Okay, here is that beautiful OB association, O and B stars, the hot stars. Look at this guy right here. See that feathery nebula, that orange nebula in there? That is a beautiful emission nebula region. It's a region where stars are being born, and they're ionized. The radiation from these young stars in here, maybe it's just a small bunch of them that we can't see, is actually causing this whole area of hydrogen gas to glow, because that's what's happening in there. All right, let me add an enhancement here. Let's sharpen this a little and see if that helps us. Yeah, so now we can see things even a little more clearly there. Okay, so if we move down this way, this is one of those galaxies that's an elliptical. Notice it doesn't really have any dark dust in it like this galaxy. It's kind of devoid of dust, and it may be devoid of a lot of gas as well. Okay, moving up here, we see right here, there's another nebular region here, another emission nebula region, where young stars are causing hydrogen gas to glow by ionizing the hydrogen gas. Okay, so that's pretty cool. And we see some details over here. Look at this beautiful dark blob right here. This is so cool. That little guy right there, that's neat. And it's 2.4 million light years away. All right, so let's go back to our histogram here. Do one more color correction. Trying to drag our curves in just a little bit, make it a little more better color. And then we'll save it with 48. And then save it exactly as seen. Okay. So there's the bottom of the galaxy, and it stretches down here even more. It goes out of the view down here. But we're going to go up to the top and do the other half, and then we'll put that together for you. Okay. So let's go back to our low light mode. This is our low light mode coming right up. Okay, there it is. And now what we're going to do is we're going to move up here, and you'll see the other galaxy at the top come into view. There it is right there coming in. That's the other satellite galaxy. And we're going to move over just a little bit. We're going to move to the east just enough. I'm going to actually capture all this. We're going to fit the width here. See where that is? We're going to actually move it enough just to put it near the edge, but not too close. Yeah, that's about right. And then I'm going to go north a bit and bring that part of the galaxy in. We want all this stuff in the galaxy that's here that you don't see. Okay, we're going to move over a little to the east again. And when this gets about here, we'll be ready. Okay, that's it. We're good. So now, we did the lower half of the galaxy. Now we'll do the upper left half of the galaxy. All right. So, this is going to be another set of 25-second exposures. Okay. And we are searching for our guide star. And let's go back to make sure that we are catching the guide star. Yep, we are. We're now guiding right there. See? Okay, telescope is still smartly pointed up. Okay, so 25 seconds. Off we go. You can see our progress bar is starting to move up. And we're going to get out of low light mode and go into deep sky mode here. And you'll see the bottom half of our galaxy. Initially, there it is. Now we're above and looking up here to the whole upper left-hand part. So this is up on the server now, and we'll clear this. And remember, guys, go to skytourlive.org, and if you can, oh, look at that, it's beautiful. If you can donate to us this Christmas season, that'd be wonderful. We're trying to get the funds to install this new telescope in the Benson location. It's a site that's even darker than this one, and it's going to be a place where we'll be able to do more imaging than we have been able to do, believe it or not. And for those that give donations, they're all tax write-offs, by the way, too, in case you're wondering. Ben Izabela's with us. Hi, Ben. Nice to see you. Ben asks, yes, it's Sharp Cap that I'm using here, Ben. I'm also using astrophotography tool. I'm using a private internet protocol camera. And then this system here is a backdrop system that I wrote to manage goings on in the observatory. So that takes care of our the housekeeping stuff, that we do. Today I was working on the new software for the new observatory in hopes that we'll have that ready. Okay, let's color correct this. The curves are a little out of line. And there we go. Look at that beautiful blues. Look at that beautiful ring of wonderful young stars, huh? Okay. Now, as this gets better, this won't be as grainy looking, and you're going to see something appearing right around here. It's an elliptical galaxy, elongated. They can be really round, or they can be stretched out long. And what we find is that this particular galaxy is neat because unlike the other elliptical galaxies we see, this one actually has a dark dust lane in it, which is interesting because not many ever have dark dust lanes in them. So this is kind of a new finding. Pretty cool. I'm hoping Friday we'll get someone out to the observatory to do some maintenance. It won't be this trip. When I go out there, January, February, I'm going to install a system that's going to allow me to manage the power to the building. Because right now, there's times where I can't manage power to the building. Oh yeah, Mr. Django asked a question. He says, did you already upgrade your all-sky camera? I did it and it's stable. Yeah, my here's our all-sky cam. Well, it's starting up. Sorry. Because I ought to... There we go. Okay. I'm only doing a short exposure here. Because I want to just see the constellations and so forth. But I'm going to change that while we're here. Thanks for reminding me. I'm going to go into my all sky settings and come down here to night settings, and I'm going to go to 12,000 milliseconds, not 120,000, 12,000. Okay, and then save changes, and then I'll be getting a 12-second shot. Okay, so let's go back up to our live view, and you will see it in just a minute. We'll drop back to see it in a minute. Boy, look at that, huh? Andromeda Galaxy never fails to impress. Never fails to impress. Let's zoom in on a few parts up here. Check this out up here. You can see some faint red nebulae here. See them? And it's mixed with dust, which is the brown stuff. Here is a more compact nebula right there. Oh yeah, that's pretty cool. Very, very cool. Yep, very cool. Alright, let's get rid of that. Let's do this. All right, we got 11 shots here. That's beautiful too. Gosh, that's gorgeous. Let's see. Oh, light. How far light travels in one of our years? Oh, well, that is the definition. A light year is how far light travels in one of our years, and that's 6 trillion miles. Alpha Centauri is 25 trillion miles away, roughly. Ben says, based on the fact that light travels 186,000 miles per second, multiply that by a year, that's exactly correct. It's actually 186,282, but who's splitting hairs at that speed, right? Yeah, Daryl's not here tonight. He actually is under the weather, so he's not joining us. I talked to him earlier. I offered him the stream tonight. He wasn't up to it. Okay. Yep, we're actually doing really nicely here. 14 shots so far. I bet that's okay. He says, thanks, Morgan. I know. I'm not being a stickler. I'm just, saying. I'm just saying, Ben. You know what I mean? Just saying. Linda Judd says, Marcus, this software is also used by other universities. Yes and no. I mean, it's, universities, they should be using Robin Glover's program. That's SharpCap here. He wrote this. And SharpCap is really brilliant. It's got a lot going on. You can study your guiding with it. You can study, like here, it's called a drift graph. It can show you where the pixels are going, with every exposure. It can help you figure out what's going on with the telescope, what's drifting which way or the other. And that's very important to figuring out what's going on. We also have a full width half maximum filter in here, and this allows us to reject images that might have elongated stars, which is why even on a windy night we no longer have ruined exposures and ruined stacks. Okay, Andy Lino is with us. Hey, Andy, C&D boy, good to see you. And Old School is back. All right. Cool. By the way, this glass, you know what they're good for? See, you can't tell, but I have Darth Vader on my ugly Christmas sweater, and it says Merry Sithmas. So you have this.
You are part of a rebel alliance and a traitor. Take him away.
So it's my Darth glass. Yeah. Yeah, Daryl will improve quickly, hopefully. Karen Belmont, you're asking some questions and I've missed some of them. I apologize. She says, I love the bands of color. Reminds me of agates. And what minerals make up the bands. Well, in galactic terms, we don't think of it that way. The universe has some selective colors that it has. It has red for ionized hydrogen. It has cobalt blue for what's called a scattering nebula, otherwise known in astronomy as a reflection nebula. That's where this brown dust in here actually scatters the blue light from stars, making a nebula a blue glow. The Pleiades has exactly that around it. We might have time for that tonight. Okay. And then there's a color of teal, a teal blue, which is the color of ionized oxygen. And, those colors are the primary colors of the universe. We think of red, green, blue here, but it's actually red, teal, cobalt blue in the universe. The teal color is sort of a cross right between green and blue, It's really pretty. Now you'll notice how dark it is here and how light it is here. That's because the galaxy, we're zoomed in on it. We gotta back out. Okay. Look at the size of the galaxy. All that young hot stars. This is the older stars in here. Let's zoom in on this guy now. Its companion galaxy, and see if we can see that dark lane in there. And I can see it if we come back here, and let's pull this back just a little bit off our dark curve. And a little more. Okay, you can see right there. See that? See that? There's a dark circle of dark dust in this galaxy. That's very rare for these types of galaxies. They typically don't have a lot of gas and dust in them. And that could be because of a collision that made them. They could have collided with this galaxy ahead of time, billions of years ago, and this is what might have been left over. And they're orbiting and doing their thing. They are definitely near this nebula, near this galaxy. They're not far away. Okay. Look at these beautiful dark clouds, huh? Let me see if we can pull them out a little more. I'm going to pull this mid-level up to get it access to fainter stuff, and I'm going to move this guy in. This is called a push. I'm going to go right to the peak. And now you can kind of see a little more detail in this dark nebula here. This is like thousands of light years long. That's incredible. Okay. All right. Oh, Michael Heydrich. Mark, can I ask you a question? If we traveled closer and closer to Andromeda, stopping for a photo every 10,000 light years, would the Milky Way starlight resolve into black space? Or would the Milky Way starlight resolve into black space, or what? I'm not sure what you mean by that. Hey, Carl Becker, how you doing? I'm not sure what you mean by that, actually, Michael. But I can tell you that as we got closer to Andromeda, I mean, well, here, let's do it. Let's get closer to Andromeda. Someday, Andromeda is going to be this big in our sky and take up most of the sky. At that point, our galaxy will already be accelerating toward the Andromeda Galaxy as they merge and swing around each other and literally become two new galaxies as a result. That's in just a few billion years. If you want to wait around for it, let me know what happens. Okay, this push I'll remove just to get us back to a nicer view here. And I'll pull this out a little bit, and you get access to the faint details again. That's cool. All right. Okay, 29 images here. Oh, look at that. Okay, let's bring that back in just a tad. So with this curve, this white curve, it's the average of the red and green and blue, as I said. And what happens is these lines, we drag these in, and this is the data that we're actually picking underneath this. Okay, we're not dragging it up here. If we did that, okay, then I'll show you what that looks like. Okay, if we had this yellow curve brought in, okay, so now we're intersecting this curve. Look at what we see here. We're catching every bit of light, and that's really bright. Now, if you do a negative of that type of thing, that's sometimes helpful, because when you do this, you can now see all the star areas and everything in this galaxy, including areas that are well defined. The inverse is very useful sometimes, you know, and that it doesn't help when you got a lit image, but when you're doing a negative, oh, it's really helpful. Okay, so that's that. Now, if we were to bring this even further, okay, it's going to get brighter and brighter and brighter. And so you don't want all the data in this curve. You want to get rid of some of it and let it taper off. And that's kind of what we're doing now. Okay. So we'll do that. All right, we'll save this again from this spot. And all right, we'll save that. Save exactly as seen. And just so you know, if you go to skytourlive.org and you go to the cool images, you're going to get this image. Actually, I want to make sure of something here. Yeah. Okay. Those lines you saw in there were just an artifact of the speed of the transfer back and forth. So as you can see, they're not really there. That's beautiful. Okay. So we're waiting for this to resolve. Now I'm going to show you. We're going to go to another object here in a bit, and let's go around the pole. And let's go here. We're going to go to Navi next because there's a beautiful nebula in here. We did this one on Halloween, and it's called the Ghost Nebula. And it's got a stunning view. I got one of the best pictures we ever took of it. And because it's high up now, this is the place to go. We're not going to do it right now. We're going to come to that though in a minute. Okay, so we're almost done with this guy. We'll go to 38 images. That's good enough for this one. So there's 37. Wow. Okay, let me see now. If you've got questions while we're waiting for the last few. Okay, Lubo says, are there any special days for astronomers? Winter solstice or autumn equinox? Well, yeah, I mean, there are some. I mean, we tend to link astronomical days to astronomical events. So, like, whenever there's a meteor shower or something, that's a fun time. When I was out working on that UFO case with Ben Hansen the other night, we were watching meteors coming from Gemini, the Geminids, and boy, oh boy, we saw, like, brilliant fireballs that went across three quarters of the sky all night long. It was incredible. But of course we were out late, and it was, and here in Connecticut, Western Connecticut, that's in the northeast of the United States, and it's cold. It was 17 degrees, and I had those chemical heaters. I had two here. I had one on each side of my chest. I had one on the top of my foot, one on the bottom of my foot, and I had in my pockets where I could put my hands in, and I had them in my gloves. So I had them everywhere, and it just barely kept up. In fact, it failed at one point, and we all had to retreat to the cars to warm up for like a half hour, and I didn't think my left foot was going to come back, but it did. You know. Okay, so 40 we're going to save here. And save exactly as seen. All right. Okay, we did it with 41. Nice. All right, so the Andromeda Galaxy then is a beautiful subject. And we'll go back now to our low light mode. And you'll see the low light mode right here. There it is. You know, in many telescopes, that's what you see. You know. Okay. Okay, so now what we're going to do is come back to this, and we're going to now go, as I promised, to the Gamma Cass Nebula around Navi, and you'll watch the telescope bend over now, leaning backwards, like it's looking way back, and it's going to go to Navi. You'll probably see Navi come into the view. That's probably it. And let's, there's Navi right there. And let's fit the width for now. Here we are. And the nebula we're looking for is right here. This is actually a very good placement, so we're going to run with that. I'm just going to tweak eastward a tiny bit. Okay. Okay. Okay, so now, here we are. Now, when you look in a telescope, this is what you're going to see. However, there is something else here, and we can do a quick look nearby, and you'll see that we have more detail, more stuff here. Okay. All right. So I'm going to move Navi a little more into the field here. Here we go. And you're going to see a beautiful nebula just showing up here in a minute. So there's a whole dusty region in here that you just don't see. Now, where are we? We're in Cassiopeia. So if we look back at our planetarium view, you'll see that we're in Cassiopeia. There's the W. Let me back out a little. The W of Cassiopeia. And the center star on the W is Navi, N-A-V-I. And Navi is where this nebula is located. So let's go check it out. There we are. So the nebula's right there. Let's do we'll do 30 seconds on this one. All right. So we're underway. You can see it over there. Yeah, Michael Hedrick, right now, there's not a whole lot of wind. I've had no failed stack images at all. And there we go. Let's put this up a little more. There it is. You can see this beautiful, extensive area. Just gorgeous. Let's pull out more of the red here. Look at that. Look at all this. Yeah, it's getting good. Hey, Stan from Two Rivers Observatory. How are you? Let's go back and look at our all sky. Okay. There we are. Okay, no moon yet. We're good. The moon is just rising here. It says it's at minus 1.1 degrees elevation. But it is past waning gibbous. So that's just past waning. It's getting smaller from 3/4 on the way out. All right, so that's good. So I can come now in and go to our, do this. So we can put our constellations in. You can see Orion down here, Aldebaran, Jupiter's right there. Okay. Yeah, lots of cool stuff. There is our Milky Way. The summer Milky Way is here, leading into the winter Milky Way here. Very nice. All right, let's get on that. All right, we'll wait on that. Oh, beautiful. Okay, let's get some contrast out of this now. Oh, look at that, guys. That's really pretty. Beautiful, beautiful, beautiful. Beautiful, beautiful. Yeah, that's just a beautiful nebula. I put it on this side so you can see the rest over here. See that? That's just gorgeous. And now's the time to take a picture of this nebula because the moonrise is going to add some brightness to the image. That's going to make it tough. Let me see how we do with our colors. Yeah, we're still good there. Let's do this. Pull this down just a little. Okay, and bring this up a little. Don't get quite to the peak because then we'll start losing data after that. Karen Belmont remembers night sky map showing the seasonal constellation. Helps a lot with positioning. Yeah, it does. It does. All right. We've had 2 rejects, so I gotta look at my full width half maximum. Ah, we're on the border, yeah, 7.68. So we got lucky. I'll just bring that up a tad. There we go. 7.74. All right, so we should catch all these now. So this is the Ghost Nebula right here. This is an emission region, and you'll notice it looks like it's got this shape to it. Well, this is Navi. Navi is an extremely hot star. Let's go look at our planetarium view and look at Navi. Let's grab Navi right here. Okay. Okay, Navi is 613 light years from us, and its spectral type is that it's a B0.5. And I think it says, does that say B? No, it might be. Hang on, I'm trying to see it, but it's hard to read with the stuff behind it. Let's see. Yeah, B0, 0.5, as I thought. Okay. It's a B0. So, this particular star's life is going to end most likely in a supernova. It's just past an O. O9 is then the next one is B0. Among the hottest stars in the universe, the O stars are. So this star is responsible for ionizing the hydrogen gas in this nebula and causing it to look like this. And if we zoom in, you'll see that there's some real detail and streaks in here that are really fascinating. See that? And Navi is responsible for taking the electrons and the hydrogen atoms in this cloud and kicking them off the atom. They absorb the energy, the ultraviolet energy coming from this very, very hot star, this hot blue star, and they leave the atom for a moment, end up running around as free electrons, and then they or different electrons come back into the atom. And as they come in, they give off that energy they had captured on the way out, and it comes out as light. And so in the hydrogen atom case, the predominant transition is hydrogen alpha, which makes an emission of red light, which is why we see red nebulae in space. Okay, it's because hydrogen alpha is occurring. But then we have this blue. This is a cobalt blue. It's not the teal blue. This blue is dark dust. See this stuff? This is all dark dust in here, all this. Okay? There's a little ionized hydrogen in here. And then we have this area here, which is more dust. But we're seeing the dust looking blue. And the reason is because Navi, its ultraviolet light and its blue light primarily are heading out to this area of space. And what's happening is the dust in this particular location is scattering the blue light and only the blue light from the star. So when it does that, it actually makes the blue light shoot out in all directions. And we end up seeing the blue light at our eyes. Our atmosphere does this. This is why we have a blue sky. And it's because the molecules in our atmosphere are scattering the blue light coming from the sun. Remember, it's a spectrum. Red, orange, yellow, green, blue, indigo, and violet coming from the sun. Well, the blue end of that spectrum is scattered in all directions because that's short wavelength, it's high energy, and that's something the dust really likes. And so the dust absorbs it and kicks it out. Well, our molecules really like that too. So it absorbs the blue light and just throws it back out in all directions. That's why the sky looks blue in every direction you look. Because everywhere it's scattering. And if you want to look up more about that, there's a term for it. It's called Rayleigh scattering. R-A-Y-L-E-I-G-H. Rayleigh scattering. Okay. So look at that nebula. Beautiful. Now you can see the filaments developing here. Look at that. Nice. So the emission, this emission nebula here is created by this hot star. And it's also ionizing stuff in here. You can see a little blue here. That's an area where the dust is actually scattering the blue light from Navi. Very, very cool. What we don't know is the three-dimensional layout of this entire structure. We don't know what it is, so it could go into the page, it could come out of the page, it could be heading for us. This here could be farther from us than this. This could be on the cusp of a leading cloud edge, and this could be way further in the background, and Navi's light isn't being scattered by the dust here as it is here. This might be closer to it, closer to Navi. Yeah, we're seeing a two-dimensional projection, remember. Yeah, old school says the moon is in southwest Arkansas. It's around 30 degrees up. Well, let's go see. The moon may be up by now or coming up. And as we go into our... Yeah, you see it's getting bright over here? The moon is coming up here. Yep. Right now it says the moon is 0.09 degrees elevation, so it's almost risen. Once it rises, we'll maybe do the Pleiades, and then, because that's bright. I'd love to show you the Orion Nebula, but we gotta wait till a little further into the season here. I did image it. It's up on the up here on SkyTourLive.org. You can see it from the other night. I was on Coast to Coast with George Norrie, and while I was on with him, I was on this side of my screen with George Norrie, and on this side, I was actually in the observatory doing imaging. And he didn't see that. I wasn't showing that. I was talking about it, but I imaged the Orion Nebula because I was on from 3 in the morning until 5 in the morning. So I was actually, you know, trying to stay awake. Look at that. Look at the detail. Let's actually do this. Let's do a zoom. Okay, let's go way in. Look at that. Look at this nebula. This is crazy. Okay, I'm too far. Hey there, Goblin. Oh, you listened that night? Great program. Oh, thanks, Goblin. Yeah, no, that was kind of a neat show. I've been on Coast to Coast with him once before, and on Coast to Coast in total about 4 times, I think. I miss Art Bell, the originator of Coast to Coast AM. He was great. Let's do a little thing here. I'm gonna back out. I'm gonna brighten things up just to look at some of the detail hiding in the background here. You can see how extensive and complex this whole region is. Now I'm gonna do something else. I'm gonna bring this back here, and now I'm gonna over process it in an instant. So watch this. This is gonna be just to see what's hiding back there. Watch this. Look what's hiding out here. There's so much out here. Wow. Let's color correct here and see if there's anything to change. And there is. Yeah, a lot more red. Look at that. See, this image will catch up to that if we let it, okay? But I can also push that out. I can push that in by doing this. You know, and then we can actually see that same view. But I prefer to not mess with it until it's ready. All right, so we've done 20 images for 30 seconds each. Really pretty. Okay. All right, so let's do a annotation here. First of all, yeah, it knows where it is, as we said. Okay, and let's take which nebula? We'll do the H2 ionized region here, and we'll set the target name to that. Okay, we'll save this annotation so people can go up to skytourlive.org, check it out. All right. I've talked to the author of this program and asked him in the past to make some changes that would be cool, and he's very responsive. Robin Glover, he's actually very, very good about doing stuff. And Richard McFarland's here. Hey there, how you doing, man? Did you get your binoculars, Richard? Richard McFarland won a pair of binoculars from us a couple streams ago. You know, and that was kind of cool. I like when people win equipment. We give away equipment courtesy of Tiffany and Mike in our chat. Tiffany Echo and Mike, who's known as Calabos. Hey, Judy M. So, Richard, I assume that means yes, you got them? Okay. I'm going to go to 25 on this. And let's go back to our all sky and see if the moon is up yet. Well, it's about 1 degree in elevation, so it's buried down here right now. That's cool. It'll be alright. Oh yeah, this is beautiful. This is, by the way, just so you know, this particular nebula, the Gamma Cass Nebula here. Gamma Cass is Navi. It's this star. Gamma Cass Nebula is a nebula that we've not been able to image before. We did, but it was very faint. And the reason is because the camera we were using was not tuned to this telescope. This camera, the ZWO 183 MC Pro, cooled camera, it's electronically cooled. Our temperature right now is minus 20 on the camera sensor. We're at minus 20 Celsius. Okay, and that's pretty cool because that means less noise and better image. So the camera we're using now is more tuned to the telescope. We're getting the right, what's called arc seconds per pixel rating on this camera, and that puts us in what's known as the exceptional range. So we're seeing detail that we just could never see before. This is only like the third time I've imaged this. It's the first time I've imaged it with all of you. I don't think I've done this publicly. I think I've done it privately only. All right, we'll save this again at 27. Okay. And remember, if you like what we do, go to skytourlive.org. There's a donate button. If you want to send us anything, that'd be great. You can also join our Patreon and become a member, a monthly subscriber. That'd be fantastic. We're building our membership slow but sure. And we'd like to bring this stuff to you. Like I said, I don't make a dime on this. I don't take a dime. No, I just give my time. Very cool. And then you can start to see the clouds in here. This dark dust is starting to take up a life of its own here. Really pretty. And remember, let's remember the size of the field here. Look at all that. This is Cassiopeia. Who would have known that that W up in Cassiopeia has so much stuff in it? My Leon says, Coast to Coast is a whole different thing. Great topics, guests, but not AB. What's AB? Sam S says, I've imaged this with you before. Okay, thank you. I kind of remember that. Yeah. Oh, Fantasy, thank you. If you guys aren't looking at the screen at 1080p, please do so. Okay, because it's going to make everything pop. You'll be able to read all this stuff if you can't. Okay, and that's kind of important. You're missing half of the data if you're not at 1080p. I should make a note about that, Fantasy. Thanks, man. Okay, 31 images. We'll say this. Sheldon Harrison, how are you? I saw you come in before. I forgot to say hi. I apologize. Okay. All right. So that's pretty. Now let's go and see. If we zoom out here, let's come out of this. Let's see what we've got waiting for us now. Can we do? I think we might be able to do. 7022 is pretty, I know that. You know what we haven't done? We'll do this. I wanted to show you this too. Okay, so that'll be the next guy we go to. So 32, we'll save this, the Gamma Cast Nebula. Thank you, Sam S, for letting me know I've done this with you before. I could not remember. It seemed familiar, yes. I know I've done it privately too. Okay. And we'll go back to our low light mode. That's a pretty nebula. And in this low light mode, we're gonna go now and head over to an extremely dangerous location in the sky. Dangerous not for me, dangerous for any stars that are near it and any potential life that might exist around it or nearby. Yeah, and it's right here, and it doesn't look like much, but let's bring it up into the field. That's a cluster of stars that we know. So bring this up. Keep that cluster in the view too, because that's really pretty. Now there's, you remember I told you about those O and B stars? They're the O stars are the hottest. Okay. Well, I sort of lied a little bit. They're normal stars. They're the hottest of the normal type stars. The stars that are currently making hydrogen into helium. All right, those are the normal stars. This star here that you see right there, that is not a normal star. That's something else. That's a star that has such energetic stellar winds that it's pushed its entire outer envelope off of itself. Now, just a little anatomy of stars. When you look at a regular star, the core is about, say, 15 to 20% of the size of the entire spherical mass. Okay, and that core is inside there. Everything outside that core is not doing fusion. It's actually just along for the ride, but it is plasma. It's nuclei only of atoms. There's free electrons zipping around within that, and there's a lot of protons in there from the stellar nuclei of the atoms, and so that plasma can be freed by the intense stellar winds and push out and leave the star. It happens for our star. It's called the solar wind, and they're charged particles. When you take the electron off of an atom of hydrogen, it's a +1 charge, and that electron's a -1 charge. So you have these particles zipping toward us from long distance, and those particles can strike our atmosphere, and when charged particles strike our atmosphere, they cause all kinds of things that we see in the night sky, namely the aurora borealis. And so the aurora borealis is something that is really, I'm going to go into low light mode and go into our deep sky mode. The aurora borealis is the result of these charged particles streaming around our magnetic field. Okay, so we'll clear this. So this star has taken and pushed all that material away. So it's known for the most powerful stellar winds, not this particular star, but stars like it. The most powerful stellar winds ever, okay, of any star. Okay, see that bluish cast? That means the moon is up. Now I can color correct it out, and I'll do it right now. Okay, here we are. But this star is made a bubble around itself, and that's all the material that was made up the envelope of the star. It's pushing it out. Very, very high power stellar winds doing that. And so this particular star is called a Wolf-Rayet star. That's Wolf, W-O-L-F, like the creature, like the animal. And Rayet, named after the other guy that discovered it. So Wolf and Rayet discovered these stars with very powerful stellar winds. All right. So that is why, that's one of the reasons why this star has pushed its material out, because it's such a powerful wind force of stellar winds. Again, most powerful stellar winds of any star in the universe. Okay, so let's grab this. It's called the Bubble Nebula for obvious reasons. There's a bubble. It's blowing a cosmic bubble. So we set that target name. All right, and we'll save the annotation. All right, we've saved the annotation. And now we can take some images. Let's go back to our all sky while we're waiting here. And we should see. It's getting a little brighter down there. Well, it's getting brighter over here. That might gotta figure out where it's rising from. It's only 2 3/4 degrees above the horizon, but you can see this whole area is brightening up now. So let's move out of this. Okay. All right, so there's our beautiful bubble nebula. Let me change our full width half maximum filter. Okay, we are getting some wind now. You can see 9.07, 8.5. It's a little bit high, so I'm going to just bring it up above the 8 guy right there. We're only capturing 2 images so far out of... Yeah, we just lost another one. Okay. Yeah. Catherine Messick also won the binoculars, and she says, I love my binoculars. Yeah, that's very cool. Very happy. We're going to be doing a lot more giveaways, guys, so we'll be giving away binoculars, and we'll be giving away telescopes, and we'll be giving away at least one night vision system that is from Psionics. That's, I think, S-Y-O-N-I-X. Psionics makes these beautiful night vision systems that are full color, and the ISO, or the rating for these, the sensitivity rating, is about 800,000. That's pretty substantial. Color correct and get the red back. Look at that. There's a little nebula here that's also here. Let's see if we named that last time. Interesting. It didn't know that nebula. Okay. Okay. Well, let's zoom in on the bubble here. And so we can just isolate it. And now you can see what's going on here. The bubble nebula is this beautiful expanding shell. Now you might say, but wait, if that's the star, how come it's not in the center? Well, there's a lot going on here. First of all, you got to understand that the star is still, it's moving through space, And we're also subject to some perspective effects, and we're subject to the fact that as this shell has moved out, it's colliding with stuff out there, causing it to distort and change its relative shape. So it's not perfect. It looks like it is, but it's not. Here you can see this really, really bright spot. This bright spot is where the material is actually really highly ionizing the hydrogen gas here. Okay, and if we were to drop this down more, you can see what it looks like. It kind of has a two-pronged effect here, and there's some dark dust in here making it look like it's got a line down there. But you'll notice now this is ionizing all this area around it, and there's a lot of dark dust here. Okay, and if a dark dust is dense enough, then this bright hot starlight can't get through. So it's interesting how this all works. Keith Evans says he loves his binoculars as well. Fantastic. Karen Belmont got some binoculars as well from us. And you know what the truth is? Binoculars are a great introduction to astronomy, because you basically go out, sit in a chair, and look up. And you see things in the universe you just didn't know were there. It is literally that good. So I believe we're catching all the images now. Yeah, okay. That's good. Nice. Karen Belmont says, Mark, do you have suggested sources for purchasing items for observing? Yeah, actually, there's a lot of places you can go. The telescope we're imaging with right here was purchased from High Point Scientific down in High Point, North Carolina. The wide field system that we're using on this telescope is from Starizona in Tucson, Arizona. Starizona has a great website. So does High Point. And you have Agena Optical. You have many different locations to give you accessories for this. You can even find them at Edmund Scientific. The venerable old Edmund Scientific. Really cool. Okay, let's get this back. You notice our curves drift a little bit, and I have to do the color correction. That's because the moon is affecting our night. Notice it's brighter up here now, so the moon's probably rising from here. It'll come across. Yep, that's gonna be a pain. But the Pleiades is almost overhead, so we'll image that next after this. And then we'll probably have to call it a night. I see there's a cloud coming in too. But this is a beautiful nebula, the Bubble Nebula. And we'll save this with 14 here. Go to 15 actually, and then we'll head over to the Pleiades. So now you learned about Wolf-Rayet stars and how they're so powerful they literally blow their outer layers off. Hey, Donald Kunzer. Donald Kunzer says, I lived a few blocks from Edmund. I love their light show. That's very cool. Yep, Edmund Scientific was great. I used to, when I was teaching astronomy around the country, I would actually go to Edmund Scientific to buy things for the talks. Okay, let's just do one last little bit of processing here. Sharpen this up, darken it up. Look at that. Really pretty. And we'll save it one more time because we can. Save exactly as seen. Alright, save exactly as seen. Okay. Very nice. Okay. Alright, now what we can do is come out of here. and go into our low light mode again for probably the final time this evening. Catherine Messick says, beautiful nebula. It is. It's beautiful, but it's deadly. The radiation from this would probably rip you to shreds if you approach within 5 light years of it. We're talking extremely powerful. And this nebula is several light years in size, by the way. So, 5 light years might correspond to like here. That would wipe you right out. Wow, that's beautiful. Bzzzt, and you're gone. Cool. All right, so let's see now. Let's do this. Let's go back here. And just for fun, I'll just do it anyway. I'm going to check to see. We'll just go to... let's go to the Orion Nebula, see how high it is. It's not going to be very high. Oh, there we go. Let's check its altitude. Altitude, the Orion Nebula is 35 degrees. It has to be higher than that for us. It has to be about 42, 43. So we'll have to come back to the Pleiades and go there because we're still just too far below. But we'll go to the Pleiades tonight. And the Pleiades, you'll notice when we go there, you'll notice where the telescope's going to go over here now. You're going to see it moving. And as it moves over, it's going to be, looking pretty much straight up. But then the Orion Nebula's out this way, and we can't get down that low. See, so the Pleiades is now there. Oh, and there they are. Beautiful. And we'll zoom out on this. We'll fit the width. All right. Very nice. Okay, so then let's go and clean up our screen. There we go. You can even see the blue around the stars here, which is pretty cool. Okay, so let's drop down a little bit and head west a little bit. This is Atlas and Pleione. This is Alcyone. This is Merope, Maya. I think that's Electra. I'm not sure. I gotta go see. Okay, move this over. So the Pleiades are known as the Seven Sisters. You know them if you've ever bought a Subaru, because that's what the hood ornament is on the Subaru, is the Pleiades, this shape. Subaru is a call for unity in Japanese, and so the Subaru icon represents unity, of your car choices and so forth. It's actually a very successful moniker. All right, let's do a 25-second shot of this. All right. Now, as we develop on this, you're going to see the blue getting better and better and better. Let's go to dark sky mode now, or deep sky mode. See, that's what it looks like in a telescope. And there's our Bubble Nebula, which is now on the server at skytourlive.org. All right, and we're 1 second from seeing the Pleiades. And here we go. Look at that. Wow. Look at that. All that in just, 25 seconds. Yeah. So let's pull this down. Look at those beautiful nebulae. Now, here's something, okay, these halos are due to our optical system. And one thing I'll tell you, Yeah, Jose Navarro says, "Whoa, no way, that's awesome. I have a Subaru." Yeah. You go look on your Subaru, you're gonna see this hood ornament right there. Don't run out now. It's kind of cold, Jose, unless you live in like a warmer climate. One of the things I wanted to mention was this dust right here. Remember I told you about the cobalt blue type color? That's what we're seeing here. Okay. This cobalt blue coloring that you're seeing, again, is that scattering of the blue light from these hot B-type stars. They're not O-type stars, but they're B-type stars, so B-type stars. And so they have a lot of ultraviolet energy that they give off. In fact, a significant portion of their spectrum comes off in the ultraviolet, not nearly as much as O stars, but B stars do. And that ultraviolet energy is sent out, and what will happen is the energy and the blue light from the stars, the blue light from the visible part of the spectrum, is absorbed by the dust particles specifically, and then scattered in all directions. So we might expect to see a slightly different color. It wouldn't be quite as blue if all the light was being scattered, but only the blue frequencies are, which is why we see these gorgeous sweeping details. Now, another thing that's interesting is the Pleiades are about 400 light years away from the Earth. And the neat thing about that, and it's recent, is that we might be looking at the Pleiades through the same dust cloud that they're in, and that we might also be enveloped in this dust cloud. Now, what does that mean about us, or for us? And that means that when we look at the dust, and if we're looking through the dust, it means that our view of the universe could actually be a little bit skewed, a little bit skewed, because we might be looking at it in a different, in a whole different way. Let me bring my thing back here. Let's drop this. Oh, what happened there? There we go. I was missing some. Okay, I'm missing some lines there. Okay. Yeah, okay. I'll grab this here. Let's just put that right here. Yeah, we're getting up pretty high. I'm not sure what happened there. I'm going to restart the stack. Don't want to end this on a bad note. I want to do this on a good note. Okay, so we'll do the live stack again. We're going to clear this stack and start over. We'll start all the way over. Okay. All right. I'm trying to find out what it's doing. I gotta wait for it to. Okay. All right, so let me turn this off for now. Go back here. Sam S., thank you for answering that for Karen. Yes, they're artifacts of the camera system, correct. We usually process them out when we do the processing on the nebula. Look at that. Oh, my gosh. That's just beautiful. Really pretty. Okay, let's Go here. Okay. We're up high in the 10s, but we're still looking good. So let's raise that up. 10.34. All right. And if we get more greens, we're good. Good. Yeah, so let's zoom in on this because I want to show you. Look at this. This is not an artifact. What you're seeing, this looks like it's brushed, kind of like combed. Okay, that is a real feature of this dust. It's a bunch of fine dust. And then up here on Maya, we have this little nebula here, which is a little more dense. This is a dust cloud, again, that is actually a dust cloud that's made of these dust particles that are micron-sized dust particles. And then we have this other combed area here. We have this cloud right here. Look at that little arc. Okay, that's a real effect. That's not something created. But the Pleiades stars, when we look at these stars, looking at them through all this dust, one thing you have to realize is this. These stars were not born here. This dust cloud we're seeing is actually something that these stars are actually passing through and illuminating it as they go through. Over millions of years, they will pass through this dust cloud, and that'll be that. They might drag some of it out with their gravity if they catch some locally. However, it's a really interesting looking feature right now. Really cool. All right, let's bring in that red curve for a minute and see what we get. Okay, that's because we are currently, there we go, a little more, and this will be that right there. Okay, let me go back to our all sky and see where the moon is. Oh, there it is. Boom, there's the moon. You can see a reflection on our all sky camera too. 6.42 degrees up, but 83.4% illuminated. When it gets 75, it'll be just at the end of waning gibbous. Okay. I hope you guys are enjoying this tonight, because it is really cool. Again, we're setting up a maintenance visit to the observatory to remove a timer, which is messing with our start and stop times. And eventually, I got a thing behind me. I wrote a circuit to actually control the power to the building, and I'm going to install that when I go out there, or I can send it out and have Marianne or Tara install it. So that's easy enough. Oh, good. Kathy Mesick says she's enjoying it. Excellent. Okay. We got 10. We'll save it here, but first we're going to do this and do nearby. Get look at that. Talk about a lot of information. Save image with annotation. Okay. Alright, so it's been saved with annotations. And now we want to find the Pleiades. And there it is, right there. Okay, notice it says Pleiades, Subaru, 7 sisters. Right? And we'll set that as the target name. Hey, where'd you go? Interesting. Why did my stack go away? Don't know why it went away. Oh, it says stack saved and reset. I didn't want to do that. Well. Oh well. We'll have to go see if I saved it. Why does... Oh, no, don't save and reset. I must have clicked save and reset. My fault, my mistake. Sorry, guys. But it's still pretty. Still very pretty. If we go inverse, you can actually see some details in the details. See the dust now? So look at out here. You see all this extra detail in here? That's incredible. Now we can remove the color, and you can see. Look at the detail. Look at this complexity in here. You don't see this complexity when we have it like this. Okay, in full color. You don't see all that complexity. You only see it when you go to the negative and look at it inverted. Now you see all this complexity in here, all these little lines, all these little details. Shows up very, very clearly here. You know, that's impressive stuff. Okay. All right. Donald Kunzer. Oops, sorry, wrong chat. Like many people, he's probably watching several things at the same time. Well, we have two eyes, so why not, right? All right, let's bring the red up a little more here. Okay. Good. All right. So it's 5. That's half the 10 we were doing. So we'll do this and save it exactly as seen. C&D boy says, I can speak typo. That's funny. Yeah. So this detail is beautiful. Again, it's one of the colors of the universe, right? Cobalt blue, this beautiful blue color. Let's see if there's anything that we can capture yet. I want to see if I can do one more. And I know that we may not be able to, but I'm going to try. Let's see. What's the altitude? 37 degrees. Not gonna be enough. Not gonna be enough. Alright. Let's see if we can do something a little different. This is gonna be a little low. Well, I'll tell you what we'll do. All right, we'll end with this one. The moon's out, so it's not going to come out as good, but we'll end with that. I'm just going to wait for this last one to come in so we can get our 10 minutes of exposure here. Or sorry, I didn't mean 10 minutes. I meant 4 minutes. All right, so we'll save it now. And save exactly as seen. Okay. So the 7 sisters, that's what they look like. Subaru. And then we will go into our low light mode. Let's go into low light mode. And head to the next object. This beautiful nebula never fails to impress, and it's in Auriga. It's called the California Nebula. It's also called the Dragon Nebula. Why? I don't know. I know, because it kind of looks like a dragon. Alright. And there it is right there. I see it right there. So what we're going to do is we're going to bring it up into the view. Hey Victor, sorry I missed you earlier. Thank you for dropping by, and we'll talk soon. Alright, so let's see here. All right, let's do this now. Okay, that might be good. This will show us a nice central spot, and we won't get Menkib over here. Menkib is the star that's causing this to light up. Another very hot star. See, hot stars, they do that, don't they? So 25 seconds. Alright. Alright, here we go. Let's get out of low light mode and go into our deep sky. Get rid of the last one we had, if I didn't do it already. The Pleiades, Subaru, 7 sisters. Oh, Richard McFarlane. Oh, look at that. That's beautiful. That's the California Nebula, a piece of it anyway. I'm going to get out of that for a second because I'm not quite happy with the position. I will get us where it belongs here in a sec. Alright, so let's do this. Let's move north a little bit. Richard, I did the Andromeda Galaxy north and south regions earlier. Kevin O'Neill. Alright, man. And let's go this way. There's Menkib. That's the star lighting it up. So let's do this. Alright, so this will be bright in here. Let's try that. Again, 25 seconds. And back to our low light mode. And I'm sorry, back to our deep sky mode, sorry. Okay, that's the previous. Now this is going to be down a little bit more. LCX 19, what's happening? Setup, you see right here, this is a 10-inch Schmidt-Cassegrain telescope that's normally at a photographic rating of f10, and we've changed it to, that's better, to be f8, which, I'm sorry, f1.8, which is a very, very fast telescope. We see things in a fraction of the time that it takes other telescopes to see them. And that red is beautifully rich. Look at that. Oh yeah, nice. And it's an automated system. I'm in Connecticut. The telescope is 2,600 miles away in the Arizona desert. And I'm running it from here in Connecticut. Hey, Tiffany, nice to see you. And this is the California Nebula we're looking at right here, which is where Tiffany is from. Tiffany's from the California Nebula. Set this target name. I could type it right in, but I'll do it this way. So, again, this is a nebula that's excited by that star that's just down here out of view. And it is a star that's extremely hot. And let me go and try and give you an idea by going into this and looking at Menkib here. Right there. I think Menkib is an O-type star, isn't it? Let's find out. Yeah. Menkib is an 07 star, 07.5, with a Roman numeral 3 after that. That means it's no longer doing normal hydrogen fusion. When those Roman numerals are anything other than the V of 5, it means it's no longer doing hydrogen into helium. So now it has left that normal path that stars are on, and it's a giant, and it's probably going to just get bigger, and it's going to go supernova someday. And When it does, this entire region could be affected by it, and we might see a change to this whole region. All right, that's beautiful though. Let's get rid of some of the moonlight here if we can. Okay, let's do it this way. Take away some of the blue. There we go. So again, this is that transition in the hydrogen atom we talked about, where it was neutral hydrogen, just hydrogen with a proton and an electron in a cloud around the proton in the nucleus. But then that electron is absorbing ultraviolet energy from Menkib, which is several light years away, and it's blowing off the hydrogen atom, leaving just a hydrogen proton zipping around. And that electron will bump into things out there, and because of collisions out there, it might it'll actually end up falling back into the atom. And when it falls back into the atom, it's going to give off light as it loses energy, as it cascades down into the atom. And the main transition it makes is to the second level in the atom, called N as in November. N equals 2. And that second point of where that the atom or the electron will stop, that's actually going to be corresponding to an energy that's released by the electron that's red light. So we see this. So it's a transition that releases red light. There's other transitions, but the dominant one is hydrogen alpha here. You can kind of see why it's called a dragon nebula, though. This is the eye. You can see a mouth here and the fire coming out. Here's the eye and the mouth and the fire coming out, if you see it that way. Pretty cool, though. Okay, we got 10 shots here. That's already good because we're cruising right along. I'll save it like this. Save exactly as seen. All sky camera, which I actually put together. This is beautiful. We can see Orion is rising higher in the sky here. There's Jupiter. In case you want to see Jupiter, let me just mention, we'll look at it again another time, but this telescope is a wide field system. The new one where we want to put in Benson, Arizona, 200 miles southeast of this one, which hopefully we can do with your donations. SkyTourLive.org, donate. Okay, that particular telescope is going to have the ability to see the planets up close. We'll be able to count multiple cloud bands on Jupiter. We'll be able to see details on the surface of Mars. It's going to be a far more magnified view. Now, we already have the telescope, so we don't need any donations for that, because previous donations covered that. But what we want to do is put it in this observatory out in Benson. We can't put it in this observatory, but when we go to Benson, we can put it in that observatory, and that's going to cost us money per month. So will Starlink. We're paying right now for Starlink for this each month to bring this to you. So if you can swing it, or if you would be able to, we'd love to be able to do a lot more for you and get this telescope in the get the telescope out of the office in Mesa, Arizona, and get it into the observatory we'd like to put it in Benson, Arizona. And by the way, we're at 3,600 feet in Benson as opposed to 1,800 feet here, so the view's even better in Benson. Okay, 15 views here. There we go. Save exactly as seen. This is the California Nebula. It goes down below, way down here and way up there out of the view. And we'll check that out at another time. But there's your California Nebula. Let's zoom in on one last little spot right here, which is really kind of cool. It's a dark nebula region. And if I pull this out a little bit, soften up the noise. You can see subtle details in here, which is really kind of cool. And if I back this off a little bit, it's gonna make everything a little softer, but you'll see more detail. See that? This is a very, very interesting, dense region of hydrogen gas. And one thing you'll notice, if we zoom out a little bit, you'll see there's a curve here. See that curve? This curve is very likely due to Menkib way out, which is like right about here in our view. And Menkib's ultraviolet radiation and solar wind, this 07.5 star, and because it goes from 0 to 09, and with divisions in between like 0.5, so 07 or 07.5. So very, very hot, but it's also putting out a lot of energy, and that solar wind it's putting out is causing this curve in the nebula. It's pushing material away, forcing this material to be somewhat curved in all likelihood. And that's what happens with very hot stars. They shape the nebula that they're near. We'll see that when we look at the rosette in the coming month. We'll see that when we look at Thor's helmet, another Wolf-Rayet star, Thor's helmet. Okay, let's see what it wants to be at here. Look at that. Let's actually do this. Ride up the curve a little, darken it up. Ah, there we go. Beautiful. Really beautiful. Okay, we'll save it. Save exactly as seen. And that's 20 exposures. And that's SkyTour live stream for tonight. I hope you guys had a good time. We will be back in the next night when the moon, as the cycle gets farther to like where moon is near the last quarter, we're going to be just fine. It'll actually be a long enough night where we can spend a lot more time looking at objects. Okay, so let's just do that. There we go. Okay. So I want to thank you guys for coming along with us. As the winter months are approaching here, we're going to be able to start earlier and earlier, and that's really, really helpful. And so we'll be running earlier in the evening rather than late at night for some of you. Okay, so you guys have a good night, and let's look forward to hanging out with each other again, shall we? All right. Hope you enjoyed. Remember, SkyTourLive.org right here. Okay, that SkyTourLive.org. You can go there and you scroll down, and you will see a. Well, let me see if I can show you. Maybe I can show it to you. Let me see if I can show you while I'm still here. Okay, let's try this. Let's go here. Will this do it? I'm gonna try something here. Yeah. Okay. So here is Arizona. You can see our two locations. Okay, that's where we are now, and this is where we're gonna go if we can, with you guys helping. All right, and it's a little bit darker than where we are. Okay, so now watch. Okay, let's go to SkyTourLive.com so I can show you. It's SkyTourLive.com, SkyTourLive.org. So here's where we are, and what we have is all this stuff, Universe Live in real time. We have a stream. This is the Comet Tsutshen Atlas that we had. This is the all-sky camera image, and we have telescope giveaway winners. Here's some of the giveaway winners. Notice Richard McFarland was in our chat tonight. So was Karen Belmont, and so was Keith E. Okay, and the Goblin. So you see, we have a lot of people in here tonight that are previous winners. Okay, and now if you want to say get photographic prints, you can do that, but there's something else too. Let's go up here. I want cool pictures. This is where you can go. Now I'm going to show you. We're going to take you to the online database right here. Okay, now at first you're just going to see folders. You can say, well, what is all that? Well, you're going to see that they are listed in order, right? So if you come down to the bottom, or depending on how it is for you, maybe it's up at the top. Okay, we have several years worth of stuff here. So from May of 2024, that's actually goes even earlier than that, all the way up. Okay, and so now we have more here. I don't see all of it. Oh, this is 2021. Hello. Okay, so I can see that it wasn't all the way in. Still loading. All right, so here's 12/18. All right, today is 12/18, so we go in that folder, and here's all the things we took pictures of. Okay, Triangulum Galaxies here. Okay, if you want to get the picture, you click on this. All right, and then this is the time we took the picture. You click on that, and then you'll see the picture, and you go right in there. This is for people that want to do astronomical image processing. You don't have to go here. If you go here, on the other hand, you see all the pictures we took. This last one we'll show you is the latest one. We went from 1700 seconds to 1800 seconds. You click it, and now here's your image, and you can download this image and take it and put it anywhere you want, do whatever you like with it. Isn't that cool? And that is how our database system works. Now we also have something else that we're working on, and I'd like to show you that too before we break here, if I may. And that is this guy. Let me just bring this up. Izabela Melamed in Bulgaria took all of our imagery and did an application for us. We're working. I'm trying to get this published to get this working. Here's that. They're all in here. Every single image is in here that we've taken all the way back to 2021. All right. This here I took the other night on the 11th. Okay. This is the Orion Nebula, and it's just stunning. This is what it looks like. Oh, check it out. These are satellites that are going through. These are geosynchronous satellites on our equator. This stuff, all this dark dust, look at this stuff. Incredible. Okay. So we actually have all of our data here. And when you click on this, it gives you the information here. You can scroll down and see. It tells you how many the exposure was. It was 20 seconds at 250 gain, which is the sensitivity of our sensor. And 27 images were stacked on top of each other to make this. So that's cool. Then we had the Running Man. Okay, the Running Man Nebula too. Look at that. It's a beautiful region. We're going to see this in even more detail. This was when it was low to the horizon. I took this picture. Just wait. Oh, we got a lot coming. Okay. So this is SkyTour Skygazer Companion that Izabela wrote. And so we actually have a number of things we're going to do to try and get that out the door quicker and get that available to you as soon as we can. Right? So that said, I hope that you guys had a good time tonight. And we will catch you on the next SkyTour. So see if you can donate, you get things like this. We're gonna provide all this stuff to you. All right. And if you join our Patreon, the upper tiers in the Patreon, you're not only gonna get highly processed images that are finished processed, you also are gonna get some swag. We're gonna get you stuff from our SkyTour shop, which if you haven't been there, you should probably check it out. SkyTour shop is on Etsy. And it's the shop where we actually have, 50 different products, which are up there. So it's right up there. Okay, right there. Okay, SkyTour shop right here on Etsy. Go check it out. Great Christmas gifts up there. Imagine a bedspread that has a giant nebula on it that we took pictures of. Okay, imagine cups and mugs and boxer shorts and sneakers and all kinds of things, lamps with nebulae on them, clocks. Okay, our lunar eclipse clock is popular. So that's all cool stuff. So that's all stuff that you can get as well, you know. And so in any case, I hope you guys, oh, thank you, C&D Boy, for putting that up. So thank you guys for visiting with us tonight. I will see you on the next SkyTour live stream. I really appreciate having you guys here, and we'll talk soon. Good night, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.